Today, I'm going to focus on one of the topics that I'm sure that everyone is, touching upon to some extent, which is vibe coding, and more specifically, vibe coding versus the reality. How do we, as engineers, stay in the flow without shipping misconfigurations, which is the kind of the silent killer, so to speak, of platform engineering, and exactly what we're trying to avoid when we're practicing. So to kick things off and just to keep things kind of engaging, quick poll for everyone here. Sam, if you can put that on the Zoom, that would be great. Again, for some of you, this might be just a part of your daily workflow. For others, might be a brand new term, vibe coding. Think about that as kind of coding in the flow with an AI assistant, moving really fast, generating lots of code, standing in the creative zone without being sort of inundated by pesky requirements and things like that. Go ahead, answer yes or no. Don't overthink it. Just click in. As the results come in, I'll explain, I'll spend a minute or two explaining what vibe coding means to me at least, or how the industry kind of looks at it, and why it's so appealing, and also why it can create some hidden challenges. So really quickly, vibe coding is really all about the rapid creative coding fueled by inspiration and assistance of AI. Not a lot of thinking, or sorry, I should correct that. Minimal overthinking, right? Focusing on the building, focusing on the mission, not on the planning, not on the minutia of syntax and stuff like that. That's taken care of by the AI assistant. Really phenomenal for quick prototyping and kind of exploring ideas, seeing how they can pan out, and feels really productive because progress seems to be really fast, very visible. It's almost like a visceral reaction. When I first started vibe coding, I was like, oh my God, what have I been missing all this time? So let's take a quick look at what the poll says right now and dive straight in. Just to give you a little better feeling about kind of what you voted, yes or no. This is a quick result from the expert and practitioner forecast. This is from a very recent research by Meter, M-E-T-R, that was conducted using a randomized control study to understand how AI tooling affects productivity of experienced open source developers. So this is a known group of developers, totally randomized, and across the board, as you can see from the results, and try to map yourself into those estimates. Both the experts and the developers believe that AI would make the experienced open source contributors work significantly faster. They're all looking at 20, 30, sometimes even 40% gains in terms of productivity and speed. Even after the hands-on use, and you can see kind of the left two bars versus the right two bars. The right two are after the experiment was concluded. This was the estimates of the practitioners and experts. They both predicted that they're going to get about a 20% gain. So that's really kind of the setting for today's webinar. What's the real world effect of vibe coding? Sam, can we see the results from the poll? I'm not sure.
Yes, we can. So I'll end the poll now. We're just about to hit 80% of participants, and we just hit 80% of participants. So there we go. I can share
Right.
And so if
Yeah,
you don't mind reading that out for everyone, because the people on YouTube won't be able to see the results. So if you don't mind reading that out.
So we've got almost 60%, 59% of the participants here said yes, they have tried vibe coding, they're using it. That's 38 participants, while 41%, which is 26 people right now online, said no, they haven't. Very interesting results, and I definitely feel like I'm, within my people, that skepticism of like, I don't know, you're on the right track. So this was not a trick question. Let's dive into kind of the details of why this matters in 2025. Well, again, unless you've been living under a rock or completely disconnected from the internet, AI and infrastructure as code are really central to building and managing software Gen AI tools have moved from novelty to everyday use. Again, I'm using it on a daily basis, constantly, really speeding up a lot of different tasks, including in development, helping teams stay in the zone, getting rid of a lot of toil, a lot of kind of menial tasks. At the same time, infrastructure as code, as we all know, became the backbone of modern cloud operations, enabling that consistency, repeatability, and scalability across the board, ridding us of a lot of kind of arcane DevOps practices where a lot of things were mostly ClickOps. Having said that, that speed and automation comes with a cost. The faster we move, the easier it is for misconfigurations to slip through, sometimes leading to downtime, vulnerabilities, compliance. And it's just not just, challenge that, of moving quickly and rapidly without breaking your cloud. That's where we're talking about today, how to keep engineers and developers in the flow state while ensuring that infrastructure that's being deployed is accurate, compliant, and secure, and not hindering our ability to move fast. So take into account the results that from this poll. Let's take a look at the complete study from Meter. So the complete study actually measured the efficacy, the practical efficacy and the productivity gains of everyone who participated. And lo and behold, this is the harsh reality. Despite the high expectations, despite having a calibrated estimate after the experience was done, which still estimated about 20% productivity gains, the developers who used AI actually took a 19% hit, basically 90% longer to complete the tasks. And again, this is a controlled study. The AI often produced suggestions that were inconsistent, low quality, or that required extra cleanup, tuning, and kind of flipping around that anticipated boost into an actual slowdown. How does that happen? How does reality kind of kicks so hard with all the promises and the billions of dollars poured into those Gen AI tools? Well, the reality check is very simple. When you're in the zone, code comes together really quickly, and with AI, it's even faster. But we need to remember, every line that you generate is still yours to maintain, debug, secure. These are the lines of code that we manually produce. Now, there's a hidden cost of vibe coding. It's essentially bringing on or multiplying the mythical 10x code that's being generated, but I did not generate it. It's some Gen AI kind of mechanism that generated it. It looks like a huge productivity boost, that speaks to the estimate of both kind of industry experts as well as developers. But again, they sort of forgot the fact that someone needs to own that code. And with all that, 10x code, there might be like 10x debugs that come with it. And moving from prototyping to production isn't really a matter of just pressing deploy. It means, sort of reverse engineering the AI generated logic, validating it against the requirements, and aligning with organizational standards. And that's where that productivity hit really comes from all that additional work that was needed to essentially validate and check someone else's code. This is not your code. This is not your logic. Now you have to sort of reverse engineer that and manage that. So kind of interesting to see how that pans out. So, the reality is that you're generating thousands of lines of code, and what you're actually doing is almost generating legacy code that you've just inherited and you need to maintain now. So again, kind of an interesting contrast between those productivity gains or supposed productivity gains as far as lines of code and structures that are being produced versus the fact that someone needs to maintain it. And especially when we're talking about engineering tasks, we cannot compromise on accuracy. We cannot live with hallucinations and issues like that. A little bit of kind of a pros and cons of generative AI. Obviously, it's a game changer for a lot of developers in terms of speed. can go from zero to a fully functional prototype in minutes. I have never seen something like that before. And trust me, I was a horrible developer in my past. I used to prototype really fast. And this stuff is just phenomenal. It's amazing for creativity, for exploration. But again, generative AI is probabilistic, all right? It's a statistical model. It's trying to predict what's likely to come up next based on other people's code. Haha, that's where you got me worried. Other people's code. That means that it's not really guaranteed to be correct, secure, or aligned with my standards. And without the guardrails and a lot of prompt engineering, you can get subtle issues and wrong outputs to kind of slip into that 10x of code that was just generated. It's not going to be compliant and sometimes dangerous in production. So it's think about that as an incredibly fast intern, great at producing drafts, but everything needs to be reviewed before it goes live. I've already talked about that. You're generating 10x the code. There's zero guarantees or probably a lot of guarantees that you're going to generate 10x the bugs. And the studies kind of back that up, both from an academic research that shows that 40% of AI-generated code contains security flaws outright. I'll be more than happy to send the links or include the links after the presentation to the study. And Sentinel-1 measured that 23% of cloud security incidents are the result of code misconfiguration. So 1 + 1, and we've got a problem on our hands. Come in deterministic AI. So far, every time I mentioned vibe coding, it was alluded that we're utilizing generative AI, and we already spoke about the probabilistic, the statistical nature of it. However, AI is not just Gen AI. AI, as we hopefully all know, is a vast field of study. It's got plenty of algorithms. It's not just LLMs and machine learning. There's knowledge graphs and decision trees and image recognition and dozens of other algorithms under that umbrella of AI. Deterministic AI is essentially the use of deterministic algorithms, again, that are better constrained or highly constrained to the data set that they're being taught on. They're typically rules and policy driven. They provide a very consistent and predictable result. Again, you're not going to ask the same question twice to get two different answers. You're going to get the same answer. Again, determinism. And it biases accuracy over creativity. Really, really a good fit for engineering when you contrast it with development or creativity. Obviously, there's pros and cons to both approaches. If we're trying to kind of cut through the different aspects that we want to look through that prism of where do we use deterministic versus generative, when we're looking for repeatability, it's deterministic 100% of the way. Generative is just not going to provide that repeatability, even though you can try to, create very sophisticated prompts. At the end of the day, you're going to spend more time prompt engineering than actually producing results. Accuracy, same thing. Again, we don't want something that is probable to be accurate. I love the saying that someone presents to me something that's like, oh, it's 95% correct. I was like, okay, so you mean that it's incorrect. So it's like, and now it's my job to find that 5% of incorrectness and fix that. Again, not really what we want as engineers who are building and maintaining platforms. We want precision and not creativity. As far as uncertainty handling, again, that's a downfall of deterministic AI. It struggles with noisy data, while generative AI really adapts to the ambiguity of that data through the probabilistic engine. So again, as always, there's no silver bullet, and it's just about choosing the right algorithm and the right approach for the right task. Again, no big surprise, Gen AI is not that shiny hammer that turns everything into a nail. We need to start thinking about what is the problem, what's the right solution for it. So obviously, when we're looking at vibe coding and utilizing AI in platform engineering, deterministic AI is sort of that missing piece of complementing the creativity and the productivity gains that can generate a lot of platforms and IAC, and coupling that with a grounding effect, with a deterministic approach that aligns everything with the documentation, with the policies that we want to ensure, with the security, with the SRE requirements, even cost that provides that that level of accuracy and repeatability that we're looking for. And of course, when we're dealing with infrastructure as code, this is the blueprint for our environments. And I don't want to, to operate in ClickOps and click through the cloud provider consoles, define everything by hand. It's not repeatable. It's not sustainable. This is really one of the foundational pillars of platform engineering, and the minimal level of maturity that we require from every DevOps and platform engineering team is utilize IAC. You have to operate through GitOps. You have to operate in a repeatable, governable fashion where you can make changes very simply through a centralized location where that infrastructure as code lives, and then you can continuously deploy that, which again brings that AI coder approach to IAC in a much more natural way for us. And again, that makes it also much more maintainable, and we can scale across different cloud platforms, which I'm sure everyone is dealing with. Curious to hear, and again, this is kind of a preempt to the next poll that I'd love everyone to start kind of clicking through, which is, how much time do you spend in correcting your code that AI produced? And this mainly relates to the 60% of you who have voted before. How much time do you spend correcting it? All that generated AI code. Options are very simple. It starts with the YOLO. That's, I had to add that to, because we all know how engineers are. Sometimes we're just like, all right, let's see if it sticks and deploy. And other times we actually do spend time, or, once we go YOLO, have to go back and it's like, all right, this didn't really work. So kind of curious to get everyone's estimates around, how much time have you spent here? If you haven't tried Gen AI code, either don't vote or put everything on YOLO, because YOLO. As you're answering that, again, quick kind of right off the cuff responses, don't overthink it. Let's talk about really optimizing infrastructure as code. So optimizing ISC is more than just writing clean scripts. It's making sure that those are reusable, like we all know, flexible and easy for teams to self-serve without introducing risk. I mean, that is the bane of a lot of platform engineering teams' existence is, that portal, those templates. How do I make it so that I can have repeatable, reusable components serviced that provides that service to all of my developers with minimal involvement from my end, and they're all blessed. They're all kind of aligned and have all the components in them, while retaining a level of flexibility. Because as we all know, you can't just take that kind of a Lego brick or a Duplo brick in some cases and tell people, all right, there you go. That's the only component you can use. They need sometimes to modify that. They need some other functionality. So there's almost like a contention between the rigidness and correctness of a paved roads approach to the flexibility that's needed by a lot of development teams. That means that, on one hand, you want to embed your organizational standards and policies directly into how IC is created, and the guardrails should not be an afterthought. They should be, continuous and automated in that lifecycle. But again, because of those constant changes, the IC should also adapt really quickly. All right. Optimization is not just a one-time task, it's an ongoing practice. So again, we can kind of see the conflict or the tension between those two approaches. So how do we maintain and how do we, kind of run those continuous self-healing guardrails? Let's talk about, the basic guardrails. A lot of them really relies on tools like SAST or DAST, manual reviews, or maybe you have some automated policy checks. The problem with those is that it's pretty much always too little, too late. SAST and DAST are really signature based. I mean, we really moved past that. They can only catch known issues in a very scripted fashion, and as such, guess what? Lots of false positives. I'm sure that everyone here has experienced a barrage of alerts and tickets, only to realize that at the end of the day, 90–80% of them are just false positives that don't take into account the context and everything and the compensating controls around it. Manual reviews, again, time-consuming, expensive, don't really scale. No one wants to spend their time kind of continuously reviewing those things. And the policy checks often happen after the code is written, which means that developers are already on the hook for the rework. So even with all those controls, we still see misconfigurations slip through. And again, my background is security. I used to serve as a CISO for a couple of quite large public organizations here in the US, and I kept seeing that happen over and over again, which sort of triggered me to start the company that I'm running right now. But again, that's the promise of AI-assisted development. This is really where we want to see the benefits of deploying AI to mitigate that manual work in a lot of those checks and provide that in context of what we're building. And that's where that continuous self-healing code really kicks in. And we can probably stop the poll, sorry, and I'll look at the results in a second. This is really where that continuous, again, self-healing code kicks in. We want to make sure that whatever that code is, whatever IAC is, whether it's at the inception phases or it's already deployed, it's continuously self-healing. So we're looking for guardrails that are adaptive and can accommodate the dynamic nature of what we're dealing here. Let's take a look at the poll results just to kind of get a sense of how much time we're all spending on fixing AI-generated code. So we've got 20%, 12 people yellowing. I love you guys. This is typically my first approach because I say, you know what, if it's not broken, let's see if it breaks in the future. And if it does break in the future, then we go to the other options. 1 to 4 hours per week is the majority. 56% of you are spending between 1 and 4 hours of just reviewing and fixing AI-generated code. That kind of sucks, to be honest. I hope that would have been better. The sad story is that, let's call it 25% of you are spending more than 5 hours. So 18% are spending 5 to 9 hours per week, and 7% are spending more than 10 hours a week fixing other people's code, and not even people. So you're really dealing with a Sisyphean task of AI-generated code that takes seconds to produce. We're spending hours and hours every week just fixing it and trying to address it. That's exactly where we need that self-healing kind of continuous self-healing approach. I see someone raising a hand. If there's a question, pop it into the chat and I will try to answer it, Vincent. So let's see, let's talk about where do we fit in. And obviously, again, in my journey from CISO to startup founder, I kind of went through those cycles of focusing on security and then realizing and meeting the phenomenal platform engineering community that this is my place. This is where things are getting fixed. And that's exactly what we're trying to do here. We fit into that automated IAC misconfiguration detection and fixes. Now, it says detection, but no one really cares about detection. I mean, you have enough tools that are screaming at you, this is wrong, go ahead and fix me. We're all about the fix. And as I alluded to before, we're delivering it through deterministic AI. I realize that, again, even as a pretty old developer, I still consider accuracy and consistency top of mind, especially when dealing with engineering tasks. That's why we're utilizing deterministic rather than generative. Yes, it would have been easier to just take off the shelf one of those chatbots and unleash them on other people's code. But again, that's where the light bulb kind of hit. And I was like, I actually don't want other people's code creeping into and other people's mistakes and bugs and security issues creeping into my infrastructure of all things. So, we've taken those strengths of the deterministic AI, applied them directly to IAC, and made sure that everything that happens within your DevOps pipelines, within your platform engineering practices, it gets reviewed, it gets fixed, again, right there and then by deterministic AI engine. And we do that through fully context-aware fixes that are ready to merge pull requests. As simple as it gets. The whole point is not to drag you into another platform, even though my UI, UX people are going to be mad at me. I don't want anyone logging into the platform. I want to meet everyone where they live, whether it's in the IDE or in their Git environments. That's where we operate. That's how we deliver those code changes to your workflows. And that means that everything from security and compliance through SRE, all the way down to cost optimizations, these things don't just get checked. They get enforced. They get fixed automatically without creating bottlenecks for the engineering teams, which means you can stop spending hours on fixing either AI-generated code or, again, other people's generated code. You can get security off your back, and that's almost a guarantee from the security guy, because you're going to close all those things and keep them at bay in a very easy to deliver manner. So again, that was kind of 25 minutes of vibe coding, reality versus, or the promise versus reality. As I mentioned before, more than happy to provide the links to the different research so you can dig through them by yourself. The meter one is really eye-opening, that stark difference between the expectations before the estimates after the experiment was done and the actual measurements from the practice is truly eye-opening, and hopefully that's going to help everyone understand what are the right tools that we should be using for the right tasks. And with that, I would love to get some questions. I saw a couple of hands raised before, and let's see. I'm going to first one, Sam. I'm using Microsoft Copilot create agents that are deployed over AppSource/Marketplace. Within the application development SDK, InfoSec and data privacy protections are embedded in these tools and apps. Please share your thoughts on using tools for vibe code development in Azure environment. The simple answer is you still need some controls. Again, I've been using Microsoft Copilot and GitHub Copilot for platform engineering. We're again, full disclosure, we're also eating our own dog food, and we're fully SaaS and in the cloud. And again, more disclosures. I used to work for AWS in my past, so I know what it's like. Less familiar with the innards of Azure. But at the end of the day, all those protections and all those controls, even though they're embedded into the marketplace, they still lack the right controls for your environment. And that's really the key. You can get a tool that was blessed by everyone under the sun, but the second you start using it and the second you start producing new code, especially if it's a generative AI one, we've all seen what that looks like at the end of the day. So again, I would highly recommend either doing a very thorough code reviews of whatever that tools are generating in your Azure environment, or utilizing continuous guardrails like the ones that we've discussed, specifically deterministic ones where you can apply your own policy. Again, it's less about someone else's kind of policy. Yeah, I've checked this, I'm compliant, and more about what do you need? What do you require for your environment for it to be, secure, stable, and resilient based on your organizational needs? And that is something that is not going to be provided by those marketplaces and platforms, unfortunately. love to take some more
So I'll just
questions. Yeah.
quickly answer I think one of the very recurring questions on the recording, because I know a few people trickled in late. So for those of you who haven't seen in the chat or don't know, yes, you will receive the recording. No worries about that. I love to see the demand for it. That's always a very good sign. So the recording, it will be on YouTube. We'll also send it to you via email. We will also send you the slides so you can more easily see all the research Ian referenced, all the great graphics in there. So no worries about that. Um, I'll then just read right away a question for you, Ian, and then you can zoom in on the chat afterwards. So from Max, quite a ways way back at the beginning, does the use of Microsoft Copilot agent development provide the security required for production? You get an enterprise data protection shield when the app meets the criteria for import into Copilot chat. Does this mean anything?
Simple answer is no, unfortunately. And again, I've kind of alluded to that before. And again, don't take my word for it. Look for any vendor that's dealing with code security these days. They love demonstrating how they're utilizing Copilot and Cursor and Duo. Again, I love them all at the same rate because they're producing a lot of work for me. They're just not able to provide that level of accuracy, the nature of it. And again, even with the most sophisticated prompt engineering, and I don't know if anyone has seen kind of the behind the scenes of what does Cursor's prompt look like from the binary reverse engineering of the Cursor product. It is extremely elaborate, and at times it's almost comical because it sounds like you're trying to convince someone to do a task they don't want. It's just the nature of generative AI. Even with the controls that are provided there, first of all, they're not your controls, and second of all, they're not consistent by definition. So, unfortunately, no, we're not there yet. And unless we'll start to utilize a measure of determinism, of deterministic AI to complement the creativity that you're getting from Copilot, you're still going to be required to do a lot of work on that.
Makes perfect sense.
I saw a question kind of pop into the chat, Sam, if you don't mind. I saw as like, is
Go
there a
right ahead.
benchmark repo? Yeah, that we can run Vibe against and see how well security problems are detected. So yes, I mean there's a couple of Goat repos, TerraGoat, and again, I'll be more than happy to send a couple of links over there as well. I know that I've been using TerraGoat or WebGoat that has some Terraform and CloudFormation in it as well as a benchmark for testing different tools and unleashing the different AI copilots, the generative ones, and see how they fare with that task of trying to protect them. Again, not to spoil the ending, but not very well. But yes, that's definitely something that I highly encourage everyone to experiment against because that's a consistent kind of benchmark that you can test those tools against. How did you create deterministic AI? Did you curate your own LLM? I love that question. And again, it goes back to my initial kind of description of the AI field in general. LLMs are not the only algorithms or approach in AI. AI has been around for decades now. We're all using it. Planes are using it on a daily basis to avoid from crashing into each other and descending in a fiery fireball. We did not create our own LLMs. We have utilized two different concepts under AI. One of them is knowledge graphs. And we maintain a pretty massive knowledge graph that covers the three major cloud providers, all of the services in them, every configuration option you can think of or that's documented, and the language definitions of the leading IAC providers like Terraform and CloudFormation. That is all contained within a pretty large knowledge graph. We're utilizing that to traverse and understand specific environments and how to accommodate for the controls that are needed for those environments. The second part is decision trees. Again, not a very sexy part of AI, still part of the AI practice. You can train decision trees to operate on a certain data set, and that's how you come up with deterministic AI. again, the AI field, very, very broad. Parts of it are, LLMs and machine learning and predictive or statistical models. Other parts like, image recognition and decision trees and knowledge graphs are much more deterministic in nature based on how they operate. So yes, we did have to create our own knowledge graph database because none of the academic ones really, fit the bill and could scale. But that was about it. The algorithms were already there. Any other questions, Sam, that you kind of saw along the way? Sorry for.
No, 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 no worries at all. I mean, there's a few questions here on kind of the nature of deterministic, the nature of vibe coding. So I think maybe it would be helpful to go over a little bit more exactly what we mean by the term vibe coding, and then maybe just spend another moment after on this idea of deterministic AI versus maybe the AI that many people in the chat are thinking about.
Sounds good. So it's actually in my key takeaways, I think. Vibe coding is really the practice of tasking an algorithm and vibing with it. All right, telling it, look, this is what I want to accomplish. Please create the code for it. I'm thinking about an environment that has backend, front-end databases, Lambda functions, Kubernetes clusters, whatever it is, please create it for me, and it generates that code. That is typically done by utilizing an LLM or what we call generative AI, where you converse with that vibe coding assistant, and it produces code that, again, is based on the predictions of what you meant. That requires, to a degree, a certain level of proficiency with prompt engineering. As I've mentioned before, sometimes you need to sort of convince it to do some things, including code. The number of times that I ran against a situation where I was like, all right, Claude or Gemini, please program this kind of function for me, and it leaves me with a quick skeleton and a couple of comments in the middle that says to do, fill the logic here. I was like, that was the whole point of me prompting you to do it. The contrast of that is deterministic AI. Again, it is less creative because it's much more structured. It's utilizing deterministic algorithms, unlike LLMs that are statistical or probabilistic in nature and produce repeatable results and accurate results. There's no hallucinations. Again, a generative AI will always try to appease you. Think about that like a glaring eye puppy. It's like whatever you do, it'll try to make you happy, even if it's not really grounded in reality. If you wanted to create something that doesn't exist, it will do it. It will convince itself that, it exists, and it'll come up with functions and capabilities that are not just not documented, they just don't exist. And again, the contrast of that is deterministic AI. I'm literally RTFMing for you. I'm going through the documentation. This is the only data set that I can utilize to produce alignments with an existing infrastructure. And that is how deterministic AI operates in the context, again, of infrastructure and code. A small caveat there, and I really appreciate, Sam, the question. The small caveat is that this operates very well on things like infrastructure as code. Why? Because the dirty secret is that we all know ISE is not really code. It's more of a script. It's much better structured. It's not like you can do the same thing in a million different ways like you can do in Java and C and Go. There's pretty much one or two ways to do everything in infrastructure as code. That makes it much more predictable and structured and much more suitable for deploying deterministic AI on it. Hopefully that answered the question and again, provided kind of a reinforcement of what we've been discussing so far. Again, it's really about that creativity boost versus the guardrails that work with you and align, kind of help you get that vibe coded material to production quality.
Yeah, really, I think super helpful for me certainly, but also for everybody here. So thank you, I think, for that zoom in. We've got a great question in the Q&A from Vincent Chan. And then I think Christian was the next one that came in. So we'll try and get to these two before we go. So Vincent asks, how have you implemented AI for secret ops? Typically, adding, removing, cycling secrets is one of the only areas where I haven't found a secure pipeline for AI to make changes to the system. I think that's a question on a lot of people's minds.
Great question. Sadly, if you know the answer to it, I would love to get that as well. No, that's something that we haven't dealt with yet. I know of a couple of companies that operate in that space. One of them actually sold recently to Okta. It's called Axiom, but again, haven't really looked at that. This is not something that we've tackled.
Mm.
So unfortunately, again, I can't help you. But again, as I said, I'd love to hear if you saw something that operates across that entire life cycle. And again, it's not just rotating secrets; it's the entire life cycle, as you alluded to. That is still something that I haven't seen properly solved. So, might be a great idea for a startup, Vincent. If you're up for it, once I'm done with Gomboc, I'm in.
Great idea. I think Vincent as well, if you take a look on the community webinars we've got coming up, we're in AI season at the moment, I think like the whole
Sure.
world. And so we've got quite a few cool AI webinars zooming on different areas. So maybe one of them will cover that topic, or probably not solve the question perfectly for you, but might have another direction you could go as well. So check out some of those. So last question from Christian. How does your tool keep up with the ever-changing cloud environments? Daily new APIs are released for deploying resources, and older ones are deprecated. Entirely new resources are released by the cloud providers, and IAC may not even be available for that.
Phenomenal question. So I have mentioned before our knowledge graph, right? This is basically what we operate based out of. Now, that knowledge graph is updated on a nightly basis. So we go through the cloud provider documentation every night. Not we, I mean, that's another task for a machine. But we ingest the documentation on a nightly basis. And as you've pointed out very clearly, I remember at least with my AWS days, the change log on AWS itself, the daily change log was averaging around 200 line items. Now, again, granted, most of them are little small modifications, but as you pointed out, some of it is, oh, there's new functionality here. There's deprecated function over there. There's a new option to overload this function and provide better functionality for that config option, or there's a brand new service that does something similar to something that you already know, but better, but different, whatever it is. That is exactly what we're ingesting on a daily basis, and that's how we update our knowledge graph. So we claim to have the perfect knowledge of all cloud providers at any given time, at least within a 24-hour window. And that is how we deliver the fixes for those environments. Now, granted, they have to have some IAC functionality in them, and that's why we also do a daily update on the definition of the languages or create specific modules to accommodate for any changes like that. There is a gray area of things that are, fresh off the cloud, so to speak, but have zero applicability in IAC. And that gray area still needs to be kind of tracked. And again, we can help track it by identifying this thing just happened, but we can't, I don't have the language to deal with it. But typically that gray area is very, very small and kind of keeps shrinking as far as the language providers, the IAC providers give that functionality. And again, the cloud providers are pretty quick to deploy and provide descriptions and capabilities in IAC for any net new services that they offer. So again, phenomenal question. And again, really aligns well with what I talked about before as far as utilizing knowledge graphs to literally RTFM based on the documented cloud provider material right back to you within, in less than 24 hours, you get the right answer, so to speak.
Amazing.
And by the way, again, I see a couple of questions here about, the availability of an MCP server to provide that functionality. Yes, we also have an MCP server. Uh, I've mentioned before, our goal is to meet you where you operate. So if it's within Cursor and VS Code and utilizing an MCP server to help you do that code alignment, absolutely, that's where we'll be. Whether it's an IDE plugin that we've just released for VS Code and is part of our community edition, which again, I've put the link here. You can freely download it. There's no need to talk to anyone. Just sign in, create an account, and you'll generate yourself a key, and you can start using that. Sorry, in your environments. So that community edition covers both the IDE plugin, MCP server, which is still in beta, and the GitHub app. So wherever it is that you want to kind of meet us, we'll meet you there. Someone asked about, okay, to send a link in connection. Yes, absolutely. Feel free to send me a link in connection. Drop a note that this is from the webinar, from the platform engineering kind of community, and I will absolutely prioritize accepting it among the barrage of LinkedIn invitations, but always happy to engage over there. My contact details are also on the last slide, so feel free to drop in a line and engage. I'm always happy to hear about your kind of struggles, figure out ways to help, or just kind of commiserate about platform engineering and why aren't we moving any faster than anyone else. And I think with that, we're almost at time. Sam, do you want to have
Yes,
any
we are
words?
indeed. Well, I want to say a huge thank you to everybody. We had, I think, over 100 people in here at one point, which in August is pretty incredible. So probably zero Europeans. All the Europeans are on holiday. So looking forward, if you're European watching this recording and enjoying it from the future. Thank you, Janelle, for sharing the docs link there that's on the screen. So if you are interested in seeing a bit more about what Ian was talking about, you can take a look at that link from Janelle, the docs.gomboc.ai. And Sebastian, you better send me a LinkedIn connection invite as well, or I'll be really jealous of Ian. So I'll be expecting that. And thank you so much, Ian, and thank you so much, everybody, for joining. The recording will be up tomorrow. We'll have an awesome bit of more content coming week over week. We've got an article coming on this same topic pretty soon, and I think tomorrow's Platform Weekly is going to be a zoom in on this topic as well. So look out for that. Thank you so much, everybody, for joining. Thank you, Ian, and have a great evening wherever you are.